The second of the four fairness criterion that we'll be discussing is the Condorcet criterion. And the Condorcet criterion says if a candidate X is a Condorcet candidate, then that candidate should be the winner of the election. So if we have a Condorcet candidate, then the Condorcet candidate should win the election. So notice that for the Condorcet criterion, the hypothesis is that we have to have a Condorcet candidate. And then the conclusion is that that candidate has to be the winner. So let's look at which voting methods satisfy this criterion and which ones do not. So let's start with the pairwise comparison method. Well, remember that the pairwise comparison method chooses a winner based on the number of points that the candidate has, and those points come from the pairwise comparisons. So by definition, a Condorcet candidate is going to beat all other candidates in a head-to-head competition. Therefore, the Condorcet candidate is going to win more comparisons than any other candidate, and therefore, if an election has a Condorcet candidate, then that candidate will always win using the pairwise comparison method. So the pairwise comparison method satisfies the Condorcet criterion. What we're going to find out, though, is that the other three voting methods that we have worked with do not satisfy the Condorcet criterion, or another way of saying that is to say that they violate the Condorcet criterion. So let's look at this one counter example, and we're going to see that the plurality candidate here, well, who has the most votes? That would be D. So D is the plurality candidate, not C, who's the Condorcet candidate. So the plurality method fails. If we were to calculate the board account winner, we would find that B is the board account winner, which is not the Condorcet candidate. So that's enough to show that the board account method fails the Condorcet criterion. And the plurality with elimination winner ends up being A, which is also not the Condorcet candidate. So that's proof that the plurality with elimination method violates the Condorcet criterion. So the conclusion here is that since we have an election that has a Condorcet candidate, but they do not win the plurality method, the board account method, or the plurality with elimination method, then that tells us that all three of these methods violates the Condorcet criterion. So again, one bad apple is enough to prove that the method violates a fairness criteria. However, remember that doesn't mean that every election using that method will violate it. It just means that every election using that method could violate that criterion. The third criterion that we'll talk about is the monotonicity criterion. And the monotonicity criterion says basically this. If you have an election and you have to have a recount for some reason, so you're doing a re-election, and in that re-election, all of the voters who make changes that favor the original winner. So let's say candidate X wins, then we have a re-election, and the only changes are made in favor of candidate X. Well, then we assume if they won originally and all of the changes favored them, then they should win the re-election. And it turns out that that is not always the case. So let's look at which voting methods satisfy the monotonicity criterion, and then look at some counter examples for those that do not. So let's talk about the plurality method. So first thing, we assume that we do have a election where X receives more first place votes than any other candidate. So in other words, X wins the plurality election originally. And then we have a re-election where the only changes made favor X. So the argument here is that if X had the most first place votes originally, and the only changes favored X, then there's no way that anybody else could gain more first place votes. So if X had the most originally and nobody else can gain more, then X is going to be guaranteed to have the most first place votes. And therefore, X will win the re-election. So the plurality method does satisfy the monotonicity criterion. What about border count? Well, again, if we assume that we have an election where X has the largest border count total, therefore they won, and in a re-election, the only changes favor X. Well, if X is being favored, then that means X is being given more points than they originally had. If they already had the most points and they are only given more, then that means that they will still have more than anybody else. So the border count also satisfies the monotonicity criterion. Well, what about pairwise comparison and the monotonicity criterion? If we have a method using the pairwise comparison method, then if candidate X beat all other candidates in a head-to-head comparison, or at least beat more than anybody else, and the position of X only improves. So in other words, the changes only favor X. If X already was beating more than anybody else and their position only improves, then they will continue to beat everybody else. So therefore, the pairwise comparison method also satisfies the monotonicity criterion. So let's look at straw versus actual votes. So an official non-binding vote that's used to gauge current preferences or see how the wind is blowing is referred to as a straw vote. So let's use the plurality with elimination method to determine the winner of the straw poll below. So remember, in round one, we are going to identify how many first place votes each candidate has. So Adams has 37, Brown has 22 plus 12 or 34, and Carter has 29. If we look at the total number of voters, we have 59, 69, 71 plus 29 would be 100. So half of that would be 50, and one more would be 51. So it requires 51 votes for a majority. Notice that none of our candidates have a majority. So we will eliminate the candidate with the least number of first place votes, which in this case is C, and then we will move on to round two. So if we eliminate C, then A now receives the 37 votes from column 1 and the 29 votes from column 4. So A, Adams, now receives 66 votes, and B, Brown, still receives 34. Since 66 is greater than 51, A now has a majority of the first place votes, and A wins. However, let's say that after that straw vote, 10 of the voters decided to switch their votes and move Adams ahead of Brown. So if you will notice that in our previous chart, this column had 37 voters and this column had 12. But because 10 of those 12 moved Adams ahead of Brown, they have now moved over into this column. So let's go back and look. See, we have 37 here, we have 12 here, but those 10 of those have moved into this column. So now let's calculate the winner of the election using plurality with elimination. So we start with round one. A receives 47, Brown receives 22 plus 2 is 24, and Carter receives 29. None of them have enough for a majority, because remember, it takes 51 or more for a majority. But notice that now C is no longer the candidate with the least number of votes. So who gets eliminated in this round? B does. And by eliminating B, these 22 votes are now going to go to Carter because Brown is no longer an option, so Carter's the next in line. And these 2 votes will now go to Adams. So Adams gets the 47 from this column and the 2 from this column, so a total of 49. Carter gets the 22 from this column and the 29 from this column, or a total of 51. So now that we see that C, or Carter, wins the election when we have these 10 voters changing, let's go back and look at what changed. Well, remember that originally these 10 voters gave Brown a ranking over Adams, and that caused Adams to win. But when these 10 voters changed from Adams to Brown, and now those 10 votes moved over here, that resulted in Carter winning. So that is a violation of the monotonicity criterion. So what we have is the hypothesis has been met because we had a original vote and then a recount, and the voter change was in favor of the original winner. However, that caused the original winner to lose. So that shows us that although the other three meet or satisfy the monotonicity criterion, the plurality with elimination method does not. The final fairness criterion that we're going to talk about is the independence of irrelevant alternatives criterion, which we will refer to commonly as the IIA. And what it says is, suppose that candidate X wins the election. So think about that. If you have somebody wins an election and a non-winner is removed, then it stands to reason that that same winner is going to win. And what we're going to see is that is not always the case. In fact, all 4 voting methods violate the IIA criterion. In other words, any of the methods that we have studied can violate. They can result in an original winner losing because a non-winner is removed. So let's look at one counterexample where we have a method violating the IIA criterion, and we're going to look at plurality method. So let's consider the burgers, pizza, and tie example, and then think about, okay, so originally who won using the plurality method? Well, burgers won because burgers received 4 votes, which was more than anybody else. But what if right before the election tie is removed? Well, once tie is removed, notice now that P has these 3 votes and pizza has these 2 votes. So pizza will now have 5 votes and burgers will only have 4. And so as a result, that means that pizza is now going to win the plurality method. So in the original election, B won, but once tie drops out, P wins. And so that means that a non-winning candidate dropping out caused the winner to change. And therefore that proves that the plurality method violates the IIA criterion.